Aurora Borealis could dazzle skies in northern United States this week. A brilliant display of auroras could grace northern skies Wednesday through Friday after the sun shot off several waves of energy toward Earth earlier this week. Activity is expected to peak Thursday into Friday as a strong geomagnetic storm, rated G3, reaches Earth. A strong G3 storm does bring the northern lights down into the United States, said Bill Murtaugh, the program coordinator at the National Oceanic and Atmospheric Administration's Space Weather Prediction Center. He said sky gazers could see the dancing light display from New England across the Great Lakes into northwest Oregon and Washington state. That is, if clouds aren't an issue. On Wednesday, skywatchers in the upper Midwest and New England may be seeing too much cloud cover to get a good view of the aurora. On Thursday, when the geomagnetic storm is expected to be at its strongest, scattered cloud cover still looks likely across parts of the northern tier of the country, although much of Montana, Michigan, New York, Massachusetts, Connecticut and Rhode Island are all forecast to have mostly clear skies. Auroras are created when the sun sends a burst of energy and particles toward Earth through solar flares, coronal mass ejections or solar wind streams. Some of the solar particles collide with Earth's magnetosphere and travel down the magnetic field lines into Earth's upper atmosphere, where they can excite nitrogen and oxygen molecules and release photons of light, creating displays known as the northern lights. In this case, several coronal mass ejections, CMEs, or large expulsions of plasma and magnetic material from the Sun, were created in a particularly active region of the Sun over the past few days. The coronal mass ejections are coming just below a gargantuan coronal hole stretching across the Sun's northern and southern hemispheres. A coronal hole spews out a fast solar wind full of particles that alone can cause some minor geomagnetic disturbances on Earth. Much of the solar energy is aimed at Earth and is expected to produce moderate to strong geomagnetic storms. NOAA's Space Weather Prediction Center has issued geomagnetic storm watches for Earth from Wednesday through Friday. There's a lot of excitement from solar physicists and space weather people, but there's no concern. There's nothing to worry about, there's no kind of impending danger coming, said Alex Young, the Associate Director for Science in the Heliophysics Science Division at NASA's Goddard Space Flight Center. He added that late Tuesday night, the first CME had only minor impacts on Earth. Some solar flares caused minor radio blackouts over the past few days. Larger solar storms also can disrupt GPS systems. On Thursday, the enhanced activity will be attributed to a cannibal CME event, which occurs when a faster-moving CME ingests a slower one. Coronal mass ejections can move anywhere from 1 million mph to 6 million mph as they travel through space, meaning that a faster-moving CME can easily overtake a slower one before it reaches Earth. When the slower CMEs are launched first and the faster ones catch up to them, they can be even more impactful, space weather physicist Tama Thiskov explained on a YouTube live stream, adding that the term is not her favorite way to explain the phenomenon, though. Cannibalism is not really true, CMEs don't really eat one another, Skov said. Cannibalism is not really true, CMEs don't really eat one another. More solar storms are expected as the Sun continues to progress through its 11-year solar activity cycle, which is ramping up toward its maximum, which Murtaugh expects it to reach between 2024 and 2025. Since we started ramping up from the solar minimum, we've had some G3-type level storms, but we haven't had greater than that yet. We've not had a G4 or higher geomagnetic storm yet in this stage of the cycle, Murtaugh said. Since we started ramping up from the solar minimum, we've had some G3-type level storms, but we haven't had greater than that yet. We've not had a G4 or higher geomagnetic storm yet in this stage of the cycle. Geomagnetic storms are categorized via NOAA's G-scale, a tool that runs from G1, a minor solar disturbance, to G5, an extreme storm capable of causing widespread blackouts, knocking out satellites for days and making the Aurora Borealis visible as far south as Texas and Florida. Certain parts of Earth appear more at risk from solar weather than others. A combination of local geology, proximity to the ocean, latitude and large interconnected power grids all play into calculating which areas are at the highest risk for disruptions caused by geomagnetic storms, according to Murtaugh. One of the most vulnerable areas, essentially, in the world is the northeast corridor of the United States, Murtaugh said, adding that parts of Canada also are quite vulnerable to solar storms. The last G5 storm to hit Earth struck in 2003, with coronal mass ejections striking around Halloween. The storm impaired satellite systems, knocked out power to parts of Sweden for an hour, and sent the Aurora Borealis as far south as Florida, according to NASA. Another disruptive solar storm struck in March 1989, causing significant breakdowns of global communications networks and knocking out power across much of Quebec for 12 hours. Just like people who live in areas where there are hurricanes or tornadoes, it's always good to have flashlights, to have extra batteries, to have some water put aside, because it's true that recent research papers have shown that the geology is such to make the Northeast slightly more susceptible, Young said.